that the force F x at the end of the angle bracket shown in the figure determine the moment of the force about point O. So we've got a force being applied. We looked at this before, but let's look at it again. So we've got a force being applied, and we want to find the moment here at this point. So one way to do it, relatively easy. You split the force into x, y components, and then you find the moment for each force. So in simple words, this force here is split into two. So I've got this force multiplied by this distance. I'm finding moment here. So this force will create a counterclockwise moment. So it's positive. And then we've got this force multiplied by this distance. I find a moment here. So that's the force line. That's my perpendicular distance, which is the same as here. And again, the moment caused by this force in the clockwise direction. So, and this will be negative. So sum of both the forces will give you the resultant, and that's basically the answer you get. And this is basically the scalar analysis, and it's basically preferred in 2D. The other way around, the vector, remember, in the vector, you need R, that is R here, and you got this F here. So R would be also a vector. Your F has to be in the vector form. So once you've got your F in vector form, you can find the moment. That's R cross F. So M naught is R cross vector R cross F, or it can be F cross R vector. Am I right?
No, sir.
Negative.
Yes, you're right. This is wrong. Cumulative property doesn't exist for the cross product. So remember, your moment is always R cross F. Always remember that. So, so you do vector approach, you get the same answer. So in simple words, the scalar approach we prefer for 2D, and the vector approach is preferred for 3D. You can use the vector approach in 2D also. It just depends what kind of information is available. So I've got two being compared here. It says that, remember, by comparison, it is seen that the scalar analysis, which is this one, provides a more convenient method for analysis than the solution 2, which is this one, since the direction of the moment and the moment arm for each component force are easy to establish. So in simple word, what is saying that if you've got the problem, you can use this approach first in 2D, but if your vector R is given, then you can use this one. So preferred one is this. That's the preference given. But remember, for 2D, for 3D, this is the preferred one. So says here, hence, this method is generally recommended for solving problem displayed in 2 dimension. It's talking about this approach. On the other hand, Cartesian vector analysis is generally recommended only for solving 3-dimension problems where the moment arm and force components are often more difficult to determine. So in very simple word, this is 2D and this approach could be 3D. You can preferred one. So the chances of getting mistake would be relatively less. So remember this.